All right, we have in a previous video graphed the parent function for the tangent, and we're going to now take care of some transformations. So on this previous slide are the steps to follow in my words, and I will break them down in this example. So we have the equation y equals 2 tangent of x divided by 2. I'm just going to go ahead and change that x divided by 2 to the tangent of 1/2 x. So we want to find the vertical stretch if it exists. So we have a multiplier of 2 in front of that tangent. So you really don't have an amplitude like you do in a sine and a cosine function, but we do have a stretch by 2 in the vertical. So if we go up to this parent function, what it does is it stretches it this point up and that point higher, so it's going to make these snakes skinnier or higher. All right, identify if a horizontal reflection exists. The A value is positive, so you don't have one. Then we want to find the length of the revolution. So it's going to be pi over b. So that's why I changed that to 1/2, so you can find your b a little easier. So you're going to take pi over 1/2, and I'm going to keep that pi, and I'm going to change that division symbol to multiplication, and then I'm going to flip that 1/2 to 2/1, and now multiply it across. So the length of one revolution, one snake, has a distance of 2 pi. So if we look at these asymptotes, normally it would start at pi over 2 and negative pi over 2. This is going to stretch out to a period of 2 pi, where the original will just be pi in its parent. Find if a vertical shift exists. There is no d value, so we do not have a vertical shift. Then we look for phase shift. The phase shift is working with this x over 2. Now there isn't a plus or minus c. So we do not have a phase shift, but we have some left and right endpoints that we want to find. So to find the left endpoint, we're going to set that 1/2 x equal to negative pi over 2, and then solve it for x. So we're going to multiply both sides by 2/1 to get rid of that 1/2 on the left. Now we multiply across, and we can cancel the common factor of 2. So we're left with negative pi over 1. So our first asymptote is going to start at negative pi. To find our right endpoint or asymptote, we set that same 1/2 x, but now equal to pi over 2. We're going to multiply both sides by the reciprocal of 1/2, which is 2/1, to undo that 1/2 on the left. Now we simplify, so we're going to cancel the common factor of 2 again, and then multiply across. So our other asymptote will be at pi. Now we're going to start to graph the tangent function. We're going to have 2 full revolutions, labeling your x and y axes, and you're going to have graphs look like snakes or cubic functions from Unit 2. So I'm going to have this be negative pi. So there's my first asymptote. And then my second asymptote is going to be at pi. Then I'm going to create those vertical asymptotes down. That's where it would be undefined. Label those as equations. X equals negative pi, x equals pi. Those are your vertical asymptotes. Now we did have a stretch vertically by 2. So I'm going to go up 2 and down 2. Between the asymptotes, you want to separate it into 4 increments. So the halfway point would be at 0. Halfway point between 0 and negative pi. So using your midpoint formula, you get negative pi over 2. And then halfway between 0 and pi would be pi over 2. So there are your 4 increments. Now, in the original tangent function, so your parent function, pi over 2, negative pi over 2, up 1, down 1, and you would graph the center and these points. So that's what the tangent function looks like for the parent. What we're going to do is graph this equation, y equals 2 tangent of 1/2 x. So we're stretching that from 1 up to 2. So this point is up here instead of at 1. And then we still have the 0, 0. And now we're going to go down to stretching that on the vertical. Now we graph our snake. So this is our stretch that's existing. And then this is our change, which is a period of 2 pi. Now you can graph more revolutions like this example. You can add another asymptote to the right or to the left and create another snake. So in this case, if you want to go to the right, you would add another revolution. So this endpoint would be at 3 pi, creating that next asymptote.